Hey, welcome back to geometry. This is sections 10.1 and 10.2, areas of triangles and quadrilaterals. Our objective is to find the area of triangles and quadrilaterals. We've already done a lot of this in preparation for our MCAS exam. So this is in preparation for our project-based assessment tomorrow, where you will design a playground with a design team, and you'll have to calculate the area of all of your features of your playground. So we're going to discuss triangles, parallelograms, rectangles, squares, kites, rhombus, and trapezoids in this lesson. Theorem 10.1 is actually the formula for the area of a rectangle. The area of a rectangle is the product of its base and its height. Base times height, and area, you are aware, is the space inside. A parallelogram is a rectangle that somebody pushed over, right? And so the formula is area is equal to base times height again, but in a rectangle, in a parallelogram, the height has to be the perpendicular segment. It can be located inside, or sometimes you have it outside like this. So let's use the area formulas. We're not going to do any easy problems here. Let's do something a little complicated. So here we have a parallelogram ABCD. We want to find the length of segment DE to the nearest tenth. So that's this segment here. Well, we know that the area of a parallelogram is base times height. If we use DA as the base, and CF as the height, because that's the perpendicular distance outside, right? It would be the same as if I had it inside, it would be 9. Then I can find the area of this parallelogram, because area is equal to base times height. So the area is equal to 13 times 9 inches. So the area is 117 inches squared. Well, now I can use this area in order to find DE, because DE is also the height, but it's the vertical height. So if I use AB instead as the base and say times the vertical height, DE, it is the same parallelogram, so it has the same area. So I'm beginning with that. The area, 117 inches squared, is equal to the base times the height. But in this situation, we're going to use AB as the base and DE as the height to solve for DE. So 117 is equal to 9.4 times height. The height, again, is DE. So we would divide 117 divided by 9.4 to find DE. So 117 divided by 9.4 will give us the length of DE, which is approximately 12.4 inches. So we use the area formula to work backwards to find that missing height. Here's another formula that you are familiar with. The area of a triangle is 1/2 base times height, and that's because 2 triangles makes 1 rectangle or 1 quadrilateral. We can use what you know to find compound area. That's when you add the area of 2 shapes together. This one is a little bit simple, and hopefully in tomorrow's project you'll use this concept. So I have this triangle on top. I want to find the area of this triangle. So area is equal to 1/2 base times height. And then we have this square on the bottom, which is the same as a rectangle. A square is a rectangle. So the area of that is base times height. Let's plug in the numbers for each one. And again, because we know this is a square, we know that all of the sides are 6. That's what those little congruent marks mean. So area is equal to 1/2 of 6 times 8. Half of 6 is 3, and 3 times 8 is 24 inches squared. And then the area of this square or rectangle, its area of a square is side squared, but base times height would still be 6 times 6. So the area here is 36 inches squared. The compound area would be when you add them both together. I'm going to add the area of this triangle plus the area of this square. So the compound area is going to equal a total of 60 inches squared. Let's talk about a trapezoid. A trapezoid, the formula is going to be 1/2 of the height times base 1 plus base 2. Remember, the bases are the parallel sides of the trapezoid. Doesn't matter which one's base 1 and base 2. When you add them together, you have the commutative property of addition, so it really doesn't matter which one you say is which. Let's try a problem here. We're going to find the area using a right triangle. What is the area of this trapezoid PQRS? Well, we know this base is 5, and we know this base is 5 and 2, so this base is 7 meters. But we need the height. We don't know the height. But what we do know is that we have a right triangle here with a given angle of 60. So it's a 30, 60, 90. If we know that the short side is 2, in a 30, 60, 90, the hypotenuse is 2 times that, it's 4. And the long leg is the short leg times the square root of 3. So our height is 2 square root of 3. So the area of our trapezoid is 1/2 of the height, which is 2 square root of 3, times base 1, 5, plus base 2, 7. So our area is 1/2 of 2 times the square root of 3 times 12. Well, I want to multiply all of these. It doesn't matter what order we multiply in. So I can multiply 1/2 times 12. What's half of 12? It's 6. Then times 2 square root of 3. 6 times 2 square root of 3 is 12 square root of 3. So our area here is 12 square root of 3. Meters times meters is meters squared. All area is in squared units. Lastly, we're going to talk about area of rhombus or kite. Remember, a rhombus is a square that somebody squished. It's got 4 congruent sides, and the lines that connect the non-adjacent sides are called the diagonals. And a kite is a quadrilateral where the adjacent sides are congruent. And again, those lines that connect the non-adjacent vertices are called the diagonals. So the area of both of these, you use the same formula. 1/2 of the diagonal 1 times diagonal 2. So let's find the area of the rhombus in a kite. So example A, we are given this rhombus. This is a rhombus. If it's a rhombus, then the diagonals bisect. So if this is 20, this is 20. So this whole diagonal is 40. If this piece of the diagonal is 30, then the other piece is 30. So diagonal 2 is 60. So the area of this rhombus would be 1/2 of diagonal 1, which was 40, times diagonal 2, which is 60. So the area here, 1/2 of 40 is 20, and 20 times 60 is going to give us 1,200, and feet times feet is square feet. So that's the area of this rhombus. Our next figure is a kite. We want to determine what are the diagonals. Diagonal LN is 3 and 3, so it's 6. Diagonal KM is 2 and 5, so it's 7. The area of a kite is the same formula, 1/2 of diagonal 1 times diagonal 2. 1/2 of 6 is 3, and 3 times 7 is 21. Meters times meters is meters squared. We also discussed the area of circles when we were preparing for MCAS. That's not included in this notes, but you will use it tomorrow in class. Remember your formula sheet. Area of circles is pi r squared, and that's the area inside of a circle. See you tomorrow.